A homeowner gets quoted $400 to fix a dead AC in July. The technician was on site for 20 minutes. And then the invoice arrived, and everything changed. The actual part cost $28 online. Think of a capacitor as the starter battery inside your outdoor AC unit. Without it, the compressor and fan motors cannot spin. It is small, cheap, absolutely critical, and statistically the first component to fail. When one goes, your AC blows warm air, hums without kicking on, or simply refuses to start. Symptoms that feel catastrophic. But here is the thing, they almost never are. But this story doesn't start with the invoice. It starts with the information gap that makes the invoice possible. Pull up any HVAC supply house catalog and search for a dual-run capacitor. You will find units ranging from $8 to $45 for premium options. This is a commodity part. It is not exotic. It is not proprietary. It is a cylindrical tin component that any electrical supplier stocks by the case. Now look at what homeowners are actually paying. According to 2026 HVAC pricing guides, the average professional replacement runs approximately $175. But real-world quotes pulled from homeowner forums, contractor review platforms, and consumer complaint boards between 2024 and 2026 tell a different story. The range runs from $250 to $800 for the same part, for the same 15-minute job. Break that invoice apart, and here is what you find. The service call fee alone runs $75 to $150 before a single wire is touched. Then labor, $50 to $100 for a 15-minute swap, and then the part itself. A $20 capacitor billed at $80 to $120 is not an outlier. It is standard industry practice. The markup on the part alone runs 300 to 500% above wholesale cost. That is the number that should make your stomach drop. But this subject wasn't done yet. Not even close. Run the 10-year math and the picture gets worse. If your system is a decade old, industry failure rates suggest you will face 1 to 2 capacitor failures over the next 10 years. At $400 per service call, that is $800 in contractor fees for what amounts to $60 worth of parts. $60. That's the kind of number that makes accountants cry. The clock was already ticking. Your system just couldn't hear it yet. The part cost is not the scandal. The information gap is. Most homeowners hand over $400 not because the repair is complex, but because they have no frame of reference for what it actually involves. They do not know what a capacitor is, where it lives, or what it costs at the supply house 3 miles away. That ignorance is not accidental. It is the product. But this wasn't just about one overpriced repair anymore. This is about a pricing architecture built on the assumption that you will never look it up. Picture the moment a technician pulls into your driveway. The service call fee has already been charged. That $75 to $150 line item exists before a single tool leaves the truck. It covers travel, time, and the diagnostic visit. And in most markets, it is non-refundable even if the tech determines nothing is wrong. That is the entry price to the information you need. Here is how the system is actually structured. HVAC companies operate on a flat-rate pricing model, which means the price for a given repair is fixed regardless of how long it actually takes. A capacitor swap takes 15 minutes. The flat-rate book might price it at $250. The technician completes the job in a quarter hour and moves to the next call. The model is not illegal, but it is deliberately opaque, and the homeowner has no visibility into the underlying cost breakdown. Technicians are often incentivized to escalate. A failed capacitor is a legitimate entry point for a broader system evaluation. That evaluation can reveal or manufacture concerns about refrigerant levels, compressor health, or system age. A $400 capacitor call has a documented pattern of becoming a $6,000 system replacement conversation. That escalation is not always dishonest, but it is structurally encouraged. The tech who closes a replacement sale generates significantly more revenue than the tech who swaps a part and leaves. The parts markup is where the profit engine really runs. A capacitor that a contractor purchases for $12 to $18 gets billed to the homeowner at $80 to $120. That delta, $60 to $100 of pure margin on a single small part, is not exceptional. It is the expectation, and it is almost never disclosed in a way that makes the markup visible. The line item says capacitor with a price. It does not say part cost $18, markup 340%. Licensing and liability are real costs that deserve acknowledgement. A certified HVAC technician carries insurance, holds state licensing, drives a stocked truck, and operates under regulatory requirements that cost real money. Those overhead costs are legitimate, but they do not account for a 400 to 500% markup on a commodity part during a 15-minute repair. The licensing argument is real. It just does not stretch that far. The core mechanism here is information asymmetry, and it is the actual product being sold. The industry's pricing power depends entirely on the homeowner not knowing what the part costs, not knowing how to replace it, and not having the confidence to try. The moment you know those three things, the leverage shifts completely. That is why this video exists, and that is exactly why the industry has no interest in making this information easy to find. This is where the story takes a turn nobody expected. Most people assume AC repair is a sealed profession, that it requires certification, specialized tools, and years of training to touch anything inside that outdoor unit. For refrigerant work, that is absolutely true. Refrigerant handling requires an EPA 608 certification and should never be a DIY project. But a capacitor replacement? That is a different category entirely. The straight answer is yes. Most homeowners can do this repair. It is consistently ranked among the most beginner-friendly HVAC repairs that exist. The process involves removing a panel, disconnecting a few wires, and connecting them to a new part. There is no soldering, no refrigerant, no specialized calibration. If you have ever changed a light fixture or replaced an electrical outlet, you have already demonstrated more technical complexity than this repair requires. The tools needed are minimal. A standard screwdriver handles the panel. Needle-nose pliers help with wire terminals. A multimeter, which runs $15 to $25 at any hardware store, is optional but genuinely useful for confirming the diagnosis before you buy the part. That is the complete tool list. There is one real danger, and it demands full respect. Capacitors store electrical charge even when the power to the unit is completely off. A charged capacitor can deliver a serious shock if you grab the terminals without discharging it first. This is not a reason to avoid the repair. It is a reason to follow one specific step. Discharging the capacitor takes 30 seconds and requires nothing more than touching an insulated screwdriver blade across the terminals. The stored charge bleeds off safely. After that, the component is inert. That single step is the entire safety protocol. Time investment runs 20 to 45 minutes for a first-time repair, including locating the unit, removing the access panel, discharging the capacitor, photographing and swapping the wiring, and testing the system. Compare that to a 2 to 4 hour window waiting for a technician to arrive, plus the diagnostic conversation, plus the invoice negotiation. The DIY path is not just cheaper, it is faster. The skill level required is genuinely low. The information barrier is the only real obstacle, and you are clearing it right now. Everything was in place. The homeowner just didn't know what everything was building toward until they looked at the label on the old part. Every capacitor carries 3 numbers that must match your system exactly. Get all 3 right, and the repair works. Get one wrong, and you risk motor damage that turns a $30 fix into a much larger problem. These numbers are printed directly on the side of the capacitor you are replacing, but they are non-negotiable. The first number is the microfarad rating, abbreviated micro F. This is the capacitance value, and it must match exactly. Common dual-run capacitor ratings pair values like 45/5 microfarad or 35/5 microfarad, representing the compressor side and the fan side respectively. Running a capacitor with the wrong microfarad rating causes motor strain, overheating, and premature failure of the compressor or fan motor, components that cost hundreds to thousands of dollars to replace. Do not approximate this number. Match it precisely. The second number is the voltage rating, measured in VAC. The two most common ratings are 370 VAC and 440 VAC. Here is the rule that matters. You can install a higher voltage rating than the original. A 440-volt capacitor in a system that originally used a 370-volt unit is perfectly acceptable and provides a small margin of safety. What you cannot do is install a lower voltage rating. A 370-volt capacitor in a 440-volt application will fail quickly and potentially damage connected components. Go up, never down. The third specification is whether you need a single-run or dual-run unit. Most residential systems use a dual-run capacitor with 3 terminals labeled HRM, fan, and COM. Single-run capacitors have 2 terminals and handle 1 motor only. The old part will tell you which type you need, where to find your specs. The label on the old capacitor is the primary source. If the label is faded or missing, check the wiring diagram typically taped inside the unit's access panel, or look up the model number on the outdoor condenser unit online. HVAC supply houses carry the widest selection at the lowest prices and can often match your specs same day. Amazon is convenient, but requires careful verification. Confirm every number before ordering. Big box hardware stores carry limited inventory at higher prices and may not stock your exact rating. Know your 3 numbers before you buy anything. That knowledge is the entire difference between a successful repair and a compressor problem. Up to this point, the process had been about preparation and knowledge. That was about to flip into hands-on execution. Cut the power first and cut it completely. Turn the AC off at the thermostat. Then flip the disconnect switch located at the outdoor condenser unit, typically a small box mounted on the wall nearby. Then go to your breaker panel and switch off the breaker labeled for the AC or condenser. 3 separate power cuts. All 3 matter. A capacitor replacement is safe when power is fully isolated. Skipping any of these steps introduces unnecessary risk. Access the capacitor by removing the side access panel on the outdoor condenser unit. This panel is typically secured by 4 screws along the edge. Remove them, set the panel aside, and look toward the top interior of the unit. The capacitor is the cylindrical component, usually silver or gray, roughly the size of a large soup can, mounted upright and connected to several wires. You will recognize it immediately. Discharge the capacitor before touching any terminals. Take an insulated screwdriver and place the metal blade across 2 of the terminals simultaneously for approximately 5 seconds. Do this across each pair of terminals. The stored charge bleeds off through the screwdriver shaft harmlessly. After 5 seconds per pair, the capacitor is safe to handle. This step takes 30 seconds total and eliminates the shock risk entirely. Document the wiring before you disconnect anything. Take a clear photograph of the capacitor with all wires attached, showing which wire connects to which terminal. The terminals are labeled HRM, fan, and COM on a dual-run unit. Pull wires one at a time using needle nose pliers on the terminal connectors. Never yank by the wire itself. Transfer each wire to the matching labeled terminal on the new capacitor in the same sequence. Match the photograph exactly. Reassemble in reverse order. Replace the access panel and secure the screws. Restore power at the breaker first, then the disconnect switch. Set the thermostat to cooling mode. A properly functioning system should have both the compressor and the outdoor fan spinning within 60 seconds of startup. Stand outside and watch. If both components kick on and the air coming from your vents transitions from warm to cool within a few minutes, the repair is complete. If you're wondering how that's even legal, billing $400 for this 15-minute process, so is everyone else. But the version you've heard about AC failures, that they always signal something serious, that's not the full picture. The capacitor is responsible for a specific and recognizable set of failure symptoms. The most common presentation is an AC unit that hums audibly but refuses to start. The motors are receiving power, trying to engage, but cannot overcome the initial torque without the capacitor's boost. A second classic symptom is a fan blade that spins only when given a manual push. The motor has just enough power to maintain rotation, but not enough to initiate it. Systems may also start briefly and shut off within seconds, or run continuously while delivering only warm air through the vents. The multimeter test gives you a definitive answer before you spend $1. Set your multimeter to capacitance mode, labeled with the microfarad symbol on most meters. Touch the probes to the capacitor terminals, HERM and COM for the compressor side, fan and COM for the fan side. A healthy capacitor reads within 5% of its rated value. A reading more than 10% below the rated microfarad value means the capacitor is failing and should be replaced. This test takes 90 seconds and removes all ambiguity from the diagnosis. You do not always need a meter. A visual inspection can be definitive. Look at the top of the capacitor. A healthy unit has a flat top. A failing or failed capacitor often shows a bulging, domed, or cracked top, sometimes with visible oil residue from internal leakage. If you see that, the diagnosis is confirmed without any measurement at all. Know what falls outside this repair. If your system is tripping the circuit breaker repeatedly, that signals a different electrical problem. Grinding or screeching noises from the compressor suggest mechanical failure. Visible refrigerant leaks require a certified technician with EPA 608 credentials. These are genuinely different problems, and they genuinely need professional attention. The capacitor replacement is powerful precisely because it covers a specific common failure mode. Recognize its limits, and you will never misapply it. One more resource worth knowing. Many HVAC supply houses will test a pulled capacitor for free. Pull the capacitor, drive it to the nearest supply house, and ask them to test it. They have bench testers that give an instant, accurate reading. Bring the old unit in before buying anything, confirm the failure, and buy the correct replacement at the counter for a fraction of what a contractor charges for the same part. The average American household spends more than $900 every year on heating and cooling. That number is not static. It moves with your system's health, and a failing capacitor moves it in the wrong direction before it ever triggers a full breakdown. A capacitor that is degraded but not yet dead forces your compressor and fan motors to work harder on every cycle. Those motors draw excess current as they strain to compensate. That inefficiency does not show up as a repair call. It shows up as a slightly higher electric bill every month for the 3 to 6 months before the unit finally quits. By the time you call the tech, you have already paid a hidden tax on the failure. The compressor is the most expensive component in your AC system. Replacement costs run between $800 and $2,000 for the part alone, not counting labor. A weak capacitor that forces the compressor to hard start repeatedly, drawing 2 to 3 times its normal startup current, accelerates wear on that compressor. The capacitor failure and the eventual compressor failure are not independent events. One leads to the other. A $30 repair ignored long enough becomes a $1,500 repair. Smart thermostat data adds another layer. Energy Star figures show that a properly programmed smart thermostat saves approximately 8% on heating and cooling costs annually. On a $900 annual bill, that is $72 to $75 per year. The number sounds modest until you multiply it across a decade. That is $700 in savings from a device that costs $100 to $150 to purchase and install. The payback period is under 2 years. The maintenance mindset is the actual shift this video is trying to create. A $30 capacitor kept on the shelf as a spare is not a paranoid precaution. It is a rational hedge. If your system is between 5 and 15 years old, a capacitor failure is a when, not an if. Having the part on hand means a summer emergency costs you 20 minutes instead of $400. That is the math the industry has no interest in you running. Pay attention to this next detail because it explains everything. The financial difference between two approaches to the same problem is not subtle. Scenario A is the default. You call a technician every time something breaks. 2 capacitor failures over 10 years, priced at $400 each, equals $800 spent. The parts involved in those 2 repairs cost a combined $60 at the supply house. You paid $740 for labor, service fees, and markup on components that required 15 minutes each to install. And somehow, it gets worse. Scenario B is what this video makes possible. You buy a $30 capacitor and a $20 multimeter. Total investment, $50. You handle both repairs yourself over the same 10-year window. Total savings on this one repair category alone, $750. The multimeter does not get thrown away after the first use. It diagnoses future electrical issues across your entire home for years. Now stack the efficiency angle. A failing capacitor that strains your motors for 3 to 6 months before complete failure adds an estimated $30 to $60 to your summer electric bills during that degradation window. Caught early with a multimeter test, that is money that stays in your pocket. Over 2 failure cycles, early detection saves an additional $60 to $120 in wasted electricity. Add the smart thermostat. At $50 to $75 in annual savings, a $100 to $150 device pays for itself in under 2 years and generates $500 to $750 in savings over a decade. That is not a speculative projection. That is Energy Star data applied to average household cooling costs. Total 10-year picture. A homeowner who learns this repair, keeps a spare capacitor on the shelf, installs a smart thermostat, and catches degradation early with a multimeter, can realistically save $1,200 to $1,500 compared to the passive, contractor-dependent approach. Not over a lifetime, over 1 decade, on decisions that take a combined afternoon to implement. The industry's pricing model only works when you do not run this math. Now you have. Next week, we are covering the one maintenance step that costs nothing and extends your system's life by years. That $28 part just became your first act of control. Subscribe so you never overpay again.